Welcome to this bite-sized session on Year 2 Occupational Specialism Assessments for Lab Science. We'll walk through this examiner feedback from Summer 25, highlighting strengths, common pitfalls and strategies to apply in delivery. In today's session, we're going to focus on the key findings from both the examiner and the moderator reports for science. We'll start by examining these findings in detail, before moving on to identify the strengths and weaknesses and common trends we've seen across assignments. From there, we'll drill down to task level performance, looking at what learners did well and where they struggled. We'll then apply this insight to explore teaching and learning strategies that can strengthen delivery and ensure learners are assessment ready. And finally, we'll consider how all this support learners' progression and achievements, making sure our teaching not only prepares students for assessment, but also equips them with the skills and confidence needed for their future roles in science. So in the following analysis, you will see RAG rating. RAG shows where performance sits by task. Green means strength, the examiner sees repeatedly. Amber means the work is partial, meets the brief, but lacks justification or evidence. Red marks occurring weaknesses. We code the examiner's comments and normalise each bar to 100%, so sections are comparable. Don't read it as marks, use it as a road map, so to shrink ambers with quick wins, like one statistic and a reference, or reduce reds by teaching the evaluation and reflection scaffolds. So now let's look more closely at assignment 1 for science and how learners performed across the 3 core tasks. So Assignment 1 overview. Assignment 1 asks learners to move from short literature review into a complete SOP for measuring river water conductivity and finish with a risk assessment. So it's research, plan, justify safety and analysis. Overall, the Chief Examiner reports notes real progress in the literature review, clear structure, better referencing and more comment on reliability and peer review. Most SOPs included the expected sections, so hypothesis, equipment, safe working and method, so the core framework is there. Where marks dropped was the results analysis inside the SOP. Many forgot to adjust site means by the distilled or pure water control, or wrote calculate the mean without showing how. In the risk assessment, hazards were listed, but the hierarchy of control and the final risk scoring were often thin or inconsistent. So let's look at this assignment in a little bit more detail. So literature review, we're looking at 3 to 5 credible sources, a 1-line claim from each, a line on trustworthiness and a final paragraph that links findings to the SOP choices. For task 2, SOP, we're looking that providers should be naming the control, for example distilled water, show means and adjusted means and specify units in the worked example. For risks, each hazard gets who, why and an appropriate control level, and a before and after task rating that matches the narrative. So let's explore assignment 1 first of all. So this is the assignment that moves from literature to an assault and risk assessment for measuring conductivity in river water. The RAG shows literature review equals mostly green, SOP mostly green and amber, with risk assessment mostly amber, with some reds where reasonings were thin. So for regards to task 1, stronger scripts were structured and referenced. They defined the focus, conductivity of river water, selected 3 to 5 credible sources and commented briefly on reliability, bias and peer reviews. Where marks dropped, justification. Learners often listed sources but didn't say why they included or rejected them, or how each source shaped their SOP choices. What good looks like is a 1-line claim from each source, a sentence on trustworthiness and a final paragraph that links findings to method of choice, for example meter type, temperature control, rinsing protocol. For task 2 SOP, most SOPs captured hypothesis, equipment, safe working and a stepwise method. That keeps a lot of response in green. The common limiter was analysis. Students frequently forgot to adjust river readings by the distilled water mean. So others produced graphs with missing units or scales that hid differences. What good looks like in this instant would be a named control, so distilled water, adjusted means shown in the worked example, a bar chart with the correct units on the y-axis, and a clear title, and two-line commentary. What does the data show and why that matters for the site comparison? For task 3 risk assessment, hazards were usually listed, so electrical, water, slips, glassware, but the hierarchy of control and overall risk scoring were patchy. Learners sometimes pasted generic risks without who might be harmed, the likelihood multiplied by the severity, or the residual risk after controls. What good looks like is each hazard gets a who or why, the control at the right level, so eliminate, substitute, engineer, admin, PP, and before and after risk rating that is consistent with the narrative. So where we move amber to green in assignment 1 is simple. Justify source selection, show the distilled water adjustment, and explain risk using a hierarchy with consistent scoring. So teaching strategies for assignment 1. So in response to these challenges, teaching strategies for assignment 1 should focus on 4 main areas. Firstly, scaffold the research question process by using exemplars so students learn what strong and weak questions look like. Secondly, you bring feasibility into the planning stage through structured checklists that prompt learners to consider resources, timings, and variables. Thirdly, model how to complete cost entries fully, showing the difference between vague and detailed responses. And finally, embed assessment practice early, perhaps through short lab diary tasks so students gain fluency with justifying controls before they face formal assessment. We now move on to assignment 2, the laboratory investigation. This section focuses on the practical skills of conducting investigations, recording results accurately and interpreting data. Let's review how learners performed. So assignment 2 has 2 practicals, each with analysis. So part A was conductivity of river samples and B chromatography with interpretation of chromatogram. So the strengths in this series, across both parts, practical techniques and safety are secure. Learners follow SOPs, handle equipment appropriately and usually compute basic means correctly. The dips are in analysis. For conductivity, many miss the adjusted mean step, subtracting the distilled water value. Graphs were sometimes tiny, lacked units, so the microsiemens per centimetre, and often omitted the 550 microsiemens per centimetre threshold line. For chromatography, techniques varied, overloading spots, handling without tweezers, limited repeats, and the analysis frequently missed baseline subtraction and tabulation. A few even invented a mean RF from a single runs. So let's look at this assignment in a little bit more detail and what we're looking for. So here's the standard we want to see. A, practical, narrate checks, probe rinsed, reading destabilized, air bubbles expelled, and read volumes at eye level. Analysis, table with mean and adjusted means, a clear bar chart with units and threshold lines, and at least a two sentence interpretation. For part B, for the practical component, we're looking at light, consistent spotting, tweezers, correct solvent level, dry properly, avoid tank movement. And for the analysis of B, measuring spot and solvent front, subtract baseline, compute RF, tabulate first, then identify or compare. So as we know, assignment 2 has the 2 practicables, and in this series it was conductivity and chromatography, each with analysis task. Practical execution trends green, with the analysis task at amber with red hotspots. So for part A, conductivity, practical techniques were generally secure, meter setup, sequence of sites and recording. Where marks slipped, probe checks, rinsing, removing air bubbles and eye level meniscus reading in the measuring cylinder. One line to push to band 4 would be narrate checks, so probe rinsed in distilled water, reading stabilised while they work. For conductivity in part A, most computed means correctly, so sorry for the analysis part, but many didn't produce adjusting means by subtracting the distilled water controls. Graphs, common issues were tiny plots, no units, missing threshold lines or axes that compress variation. So what good would look like in this instance would be table with mean and adjusted means, a bar chart with units and threshold, and at least a two sentence interpretation. Site B exceeds threshold, site C is close, environmental explanation offered briefly. For part B, the chromatography practical component, setup and safety were fine overall. Techniques dropped where learners overloaded spots, skipped repeats, or handled plates without tweezers. So remind learners light spotting, capillary control, consistent solvent height, and drying before development. For the Part B analysis, measurements were often accurate, but the baseline subtraction was commonly missed. Tables were sometimes absent. A few invented a mean RF from single runs. So what good would look like is tabulate distance of spot, distance of solvent front, compute RF, which would equal spot minus baseline divided by front minus baseline, then a short comparison statement, for example, sample versus reference. So to close, amber turns to green in A2 when the standardized analysis conventions adjust means for conductivity, units and thresholds and graphs, and baseline corrected RF with proper tabulation. To support students in assignment 2, teaching strategies should be tightly focused on accuracy, reliability, and presentation. Begin with regular practice in routine calibration and precision use of pipettes and balances, so learners gain fluency. Secondly, embed the concept of reliability by insisting on repeat trials as a standard practice in everyday lab sessions. Thirdly, reinforce conventions, particularly units, significant units, and consistent notation across all lessons, not just during assessment preparation. Finally, make strong use of exemplars showing students what a well-constructed data table or a correctly scaled graph looks like, and modelling the difference between incomplete and complete presentations. These approaches can move students from amber into green performance. So we'll now move on to assignment 3, which combines a scientific report with a professional discussion. This assignment is designed to test not only learners' ability to evaluate and synthesize evidence in writing, but also their capacity to articulate their understanding verbally, linking ideas to professional practice. So assignment 3 is pure data analysis task. Learners must comment on reliability, identify and explain errors, give causes and reductions, and complete the statistical graphing. Means, standard deviation, error bars, justified best fit, and appropriate extrapolation. So compared with the last series, there is less confusion between reliability and types of errors. Some learners now provide a more balanced reliability comment. The biggest gaps are in critical analysis and statistics. Many can spot errors but don't explain the mechanism, how that error arises from method, or its direction of effect. Causes and reductions are listed without reasoning, and the states or graphs element is the main red. So that would be the standard SD versus over the error bars missing, best fit, not drawn or not justified, and extrapolation rarely bounded. So a little bit more detail of what we're looking for on assignment 3. So reliability, we're looking for a strength plus a limitation tied to the data pattern. For errors, we're looking at identify plus because clause linked to the method. So for example, reading before stabilization to random error. For task 3, causes and reductions. For task 4, and give a plausible mechanism and how the fix would improve a metric. For example, SD decreases. For task 5, the statistics or plots, compute mean and SD, plot means with error bars, draw the justified best fit, comment on outliers, extrapolate cautiously, as in state the limits. So this is the most discriminating assignment. The RAG shows reliability around green and amber, while errors cause these reductions sit in amber, and statistics and graphing is the major red. So task 1, reliability. Stronger scripts balance strengths and weaknesses, repeatability, consistency across sites, years, and notes on sampling out conditions. Weaker ones make generic claims, so for example, reliable, without evidence. So what we're looking for is a sentence on why it's reliable. Replicate, agree, small spread, and then sentence on why not. Cite C varied, weather confound. Task 2, identify and explain errors. Most could spot errors, for example, inconsistent volumes, contamination risks, but often didn't explain mechanisms, how that specific error arises in their method. So what can we do? What we're looking for is the student to pair each error with a because clause tied to the procedure. So reading taken before stabilization, because random error increasing spread. For task 3, causes of error, causes were listed, human instrument and environment, but reasoning was thin. Some misunderstandings persisted, for example, treating single-use items as reusable. So what we're really looking for is a plausible mechanism per cause and the direction of effect. Would it raise or lower the result? For task 4, ways to reduce error, learners named controls, repeats, calibration, SOPs, but didn't quantify impact. So what good looks like is pair each mitigation with how it helps, and if possible, what metric would show improvement. For example, SD drops, fewer outliers. For task 5, statistics and graphing, SD, error bars, best fit, and extrapolation. This is the poorest error, missing standard deviations, no error bars, and absent or unjustified line of best fits were common. So assignment 3 is where those higher skills are won or lost. If we normalise the habit, identify, explain, reduce, and always pair findings with SD over error bars and justify best fit, we move a large block from ambers and red into green. To address the challenges in assignment 3, teaching strategies should aim to strengthen both written and verbal skills. First, provide learners with structured reflective prompts to deepen their evaluation. For example, asking them explicitly about validity, reliability, and possible improvements. Second, build academic integrity through short, regular mini-tasks on referencing so students become fluent in citation conventions. Third, encourage rehearsal of professional discussion using peer Q&A so learners can practice articulating their ideas under semi-formal conditions. Next, link scientific reports directly to the learner's own data, ensuring that evaluation and recommendations feel relevant, concrete, and easier to expand upon. So for example, for statistics and graphing, teach a simple writing frame. Compute mean and SD, plot means with SD error bars, draw and justify the best fit line, so linear over non-linear and Y, comment on outliers or anomalies, and extrapolate cautiously. State limit prediction only with an observed range. Access housekeeping units on both axes, readable scale, and a title that states what and where. Together, these approaches can help shift task 1 performance out of red and ambers and ensure task 2 continually moving towards green. So we'll now step back and look at the overall trend across all assignments. This helps us see the bigger pictures, the strengths that are consistently emerging, but also the persistent weaknesses that we need to address through teaching and support. So across the science OS, practical technique is green. Students can perform the method safely. Where mark drops is the thinking around data. So assignment 1 and 2, learners often miss adjustments such as distilled water or baseline subtraction and produce graphs without units or scale threshold, hence the large amber for data handling and graph standards. The statistic theme is the clear red hot spot. Standard deviation and error bars are rarely shown and best fit lines aren't justified. In assignment 3, reliability is discussed more than last series, but answers need a balanced views of strengths and weaknesses. Learners commonly identified errors but didn't explain mechanisms or evaluate impact, so evaluations and justification stays amber and red. Documentation is generally fine, though SOP reasoning can be thin. Bottom line, keep the strong practicals and teach a routine for analysis. So adjust, tabulate, plot with units and thresholds. SDs are error bars, best fit to interpret, to move big amber red blocks into green next series. So what do we do with these trends? So we'll focus on cross-cutting strategies that lift performance across all assignments. First, bring evaluation and risk assessment practice in early and keep it regular. Don't wait for assessment windows. Second, math is pivotal. Start from learners' end of year 1 baseline and deliberately extend into year 2. That means daily low-stake use of significant figures, unit consistency, scaling, graphing and error or uncertainty within routine lab and class tasks, so these become automatic. Build quick 5 minutes math and context drills into practicals and co-plan with math colleagues so conventions match. Same rounding rules, same graph expectations and same vocabulary. Third, strengthen internal standardization with exemplar packs so judgments are consistent and fair. Fourth, scaffold independence. Begin with worked examples and checklists, then phase these out so learners evidence authentic understanding. And finally, embed reflective practice-based discussions. Learners should routinely explain choices, limitations and improvements, linking science to real context. Applied consistently, these moves tighten both written and verbal performance and directly address the persistent weaknesses we've seen. So as we come to the end of this session, I'd like to take a moment to reflect on some common themes and how we continue to support. So support doesn't stop after today's session. So there is a range of materials available to help you and your learners. So on the NCFE qualification page, you'll find the Chief Examiner report, student exemplar work and downloadable schemes of work with teaching materials. There are also recorded CP sessions on our YouTube playlist, which you can revisit at any time, and upcoming live events listed on the NCFE T-Level Training Events page. All of these are designed to make your delivery smoother and your learners more confident. So before we finish, we'd really appreciate your feedback on today's session. You can scan the QR code on the screen or follow the link in the description to this video to complete a very short survey with the title T-Level Science Year 2 Summary 25C Report. Your input helps us to refine our training and makes your future sessions are as relevant and useful as possible. So thank you for engaging with this session on Chief Examiner Moderator Insights for the Science Occupational Specialism of Lab Science. These reports give us clear lens into learning performance, where they succeeded, where they struggle, and how we as educators can make the difference. By applying the strategies we've shared today, you can embed deeper reflection, strengthening technical fluency, and build the professional competence your learners need. We look forward to continue this journey with you as we support the next generation of science professionals.